All right, guys, welcome to our Unit 10 study guide. Just going to go through the even ones like always. I will provide the answers to the odds on the study guide. You guys are going to do the evens. Odds are included just for extra practice in case you want that. So our goal here on number 2 is to find the measure of this red arc. And so let's begin. Now notice, first of all, we're going clockwise, so that means we're dealing with a negative angle. Now right there, I just completed a full circle. And right here, I've just completed a half circle. And then finally, there's a little extra piece right here also. So I've got 3 parts, all right? I have the red angle there, the red arc, all the way around one full circle is, notice that we're doing degrees right now. So a full circle in degrees is 360. Next, we have the green part that I've highlighted here. That's half of a circle. And in degrees, half of a circle is 180 degrees. And then finally, we have that little purple part, but I actually don't know that right now. I need to figure out what that little missing piece is there. And what we learned in class is that for these pictures here, we have quadrants. So like this is a quadrant, this is a quadrant, and this is a quadrant. Each of these quadrants is 90 degrees total. Okay, so if this quadrant here all the way across is 90 degrees, and this much of it is 80, we can find the missing piece if we just subtract it from 90. So in other words, the missing piece plus 80 should add up to make 90, right? And so most of you guys could probably just do that in your head, but I'll still show my work here. I'm going to subtract, and the answer is, for the missing piece, 10 degrees. And so that's what we'll go over here for the purple. So this little missing angle over here is 10 degrees. And that was our last part that we need to add in there. So we have 360, 180, and then 10. So let's go ahead and put all those together and see what we get. And that's 550 degrees. But let's not forget that was a negative angle, so we're going to make it negative 550. And there we have it. All right, so this is number 2. Let's go ahead and take a look at yet another, number 4. Same kind of question, but this time notice that we have a pi instead of degrees. That means we're doing radians instead of degrees. So whenever we do a full circle with radians, it is equal to 2 pi. So my first red arc there is equal to 2 pi. But we're not done. We need to add some more to it. So what else do we need to add? We need to go from here to here. Now that's a quadrant, right? That's one of the quarters of the full circle there. So that is equal to pi over 2. Quarter of the turn is equal to pi over 2. Each quadrant is pi over 2. And then finally we have this last piece, which once again is a missing piece. So we don't really know what that one is. But once we do figure out what that is, we're going to add all 3 of these up, and that will be this arc. Now this is a positive angle because we are going in a counterclockwise direction. So how do we find the missing piece when we're dealing with radians? Well, in kind of a similar way that we did the degree one, it's just that instead of each quadrant equaling 90 now, we say each of these quadrants equals pi over 2. So I know that this 2 pi over 9, if I add that, if I add this angle to this missing piece, which I don't know yet, so I'll just call it question mark for now, that should give me the full quadrant, which is pi over 2. And so we just need to solve this equation here. So the first thing I would do is I would minus the 2 pi on both sides. That way I can get the question mark by itself. As you guys can see though, now that we've got the question mark by itself, we need to get a common denominator. So what's a common denominator for 2 and 9? What would be 18? So I'm going to multiply this side by 9 to make 18 on the bottom. And I'm going to multiply this denominator by 2 to make 18 on the bottom. And whatever you do the bottom, you do the top, of course, right? So now we have our question mark, our missing piece, is equal to this, which is 9 pi over 18. Minus this, which is 4 pi over 18. Oops. So now that we have a common denominator, we can go ahead and subtract these. 9 pi minus 4 pi would be 5 pi. So now I know my missing piece. It's 5 pi over 18. And so that's the missing piece that would go here. And I'm going to rewrite that. 5 pi over 18. And since that's my missing piece, now I can plug that in over here to find the total. And there you have it. So here we go. Let's review. So a full circle is 2 pi. A quarter circle is pi over 2. And then we have our missing piece, which is 5 pi over 18, which we found by doing all this. Now we're ready to add together all those pieces here in order to get the total. And once again, you're going to need a common denominator. So you can think of this 2 pi here as 2 pi over 1. And now we have to ask ourselves, what's the common denominator for 1, 2, and 18? Well, it's 18. So I'm going to multiply the top and the bottom of this one by 18 in order to get my denominator to be 18. For the next one, I'm going to multiply the top and bottom by 9 in order to make 18. And then for the last one, it's already 18, so I'll just leave it alone, right? So after simplifying that, this one becomes 36 pi over 18. This one becomes 9 pi over 18. And then this one is the same. And we're pretty much ready to add all these numerators together now. 36 plus 9 is 45, plus 5 is 50. So we have 50 pi over 18. And of course we should reduce if we can. I do know that the top and bottom can both be reduced by 2, so that's 25 pi over 9. And I don't think it can be reduced any more than that. So there's our final answer. And that's the radians of that particular arc. All right, let's go ahead and move on to number 6 here. Number 6 is asking us to find a positive and a negative coterminal angle for the angle that they give us. So to find a positive, what we're going to do is we're going to take the angle that they give us and we're just going to add 360 to it. That's going to give me 5, 8, and 5. A coterminal angle is an angle that's on the unit circle, it looks the same. So for instance, 225 degrees is here, and the arc looks like that. But if you go around another full circle, you're back to where you started, right? And so that's 225 plus 360. So you end up at the same spot, even though it is actually a different angle. And so that's what we mean by coterminal angles. So you can find those by just adding 360. Likewise, you can create another coterminal angle by subtracting 360, which would be like rotating in the opposite direction. So 225 minus 360 is negative 135. So now I've got one positive and one negative coterminal angle. Right. So that's how we find coterminals in degrees. But what about with radians? Well, when it comes to radians, instead of adding 360 or subtracting 360, we add 2 pi or we subtract 2 pi. So to get your positive, we're going to take the 83 over 36 and we're going to add to it 2 pi. Okay? Now to do that though, we're going to need a common denominator. The common denominator for 1 and 36 is 36, so I'm going to be multiplying the top and the bottom by 36, which will cause the following. The first fraction is going to stay the same because I didn't multiply it by anything. But the second fraction now will be 72 pi over 36. And of course, we're going to go ahead and combine these now. So that's going to be 155 pi over 36. Okay, so I don't know, can this be reduced or not? Well, I know that 36 can be divided by 3, by 6, by 2, by 12, by 9, by 4. I don't think any of those go into 155, so I'm pretty sure that's just going to stay just like that. But you can always use a calculator check to make sure. All right, so that's my positive coterminal angle. Okay, let's find our negative one. You're going to do it in the same way. So we're going to do 83 over 36, but minus 2 pi. Now, same thing's going to happen here. We're going to multiply the top and the bottom by 36. So if I do that, you're still going to get the same thing as the last time. We're going to end up with 72 pi over 36, but remember, we are subtracting this time. So now if I subtract 83 and 72, I think I'm going to get 11 pi over 36, and that's not my answer. Believe it, I thought I was done, but it's not. Why not? Because the problem has asked me to find a positive and a negative coterminal angle. So this is a positive coterminal, but guess what? So is this. That's positive also, right? I don't have a negative yet. So I actually have to do this again. So now I have to take 11 pi over 36, and I have to subtract 2 pi again. Now once again, if you get a common denominator, it's still going to be 72 pi over 36. So now let's do that. So if I subtract these two, what's 11 minus 72? I believe that's going to be negative 61 pi over 36. So sometimes you'll have to subtract more than once. Now I'm going to leave all three of these answers up here because whenever you have your multiple choice test, they're not going to have both of these positives. They're only going to pick one. So it's nice to have them both available. I'm kind of curious to see how this software will do it. Let's see what it does. I think it's going to do the two smallest ones. So I think it's going to go for 11 pi over 36 and negative 61 pi over 36. Let's see. Yep, there it is. So they go with the 11 and this one. This is still a coterminal angle. There's technically an infinite number of these things. You can keep adding 2 pi and keep creating more and more and more. But they just go with the two smallest ones. So there you go. So we did a little unnecessary work here to begin with. It happens. It's part of the deal with these, but we got it done anyway. All right, let's go ahead and move on to number 10. So this one says convert each degree measure into radians. So whenever you're converting degrees into radians, you're going to multiply by pi over 180. Okay, so I'm going to take negative 670, and I'm going to multiply that by pi over 180. So think of this as over 1, and we end up with negative 670 pi over 180. We do need to reduce, though, if possible. Since they both end in a 0, I can divide both the top and the bottom by 10 and get negative 67 pi over 18. Can I reduce this anymore? I don't think so, because the only thing that goes into 18 I know is 2, 3, 6, and 9. And I know 9 doesn't go into 67, neither does 6. 3 doesn't work, and neither does 2. So no, it's not going to reduce anymore. We're done. So the answer would be negative 67 pi over 18. All right, similar question, but it's the reverse. How do we convert radians into degrees? Well, instead of multiplying by pi over 180, we multiply by 180 over pi in this case. So I have 17 pi over 36, and I want to multiply that by 180 over pi. Okay, so the pi's cancel, of course. And for these ones, I like to reduce ahead of time. Now, I know that 18 goes into 36, and goes in there twice, actually. So if I divide this by 18, I'm going to be left with 10. And if I divide this by 18, I'm left with, I think I said 2, right? Yeah, 2. So now I've got 2 there and 10 on the top, but still we can reduce more because now I know that 2 goes into 10 5 times. So there we have it. So all I'm left with now is 17 on the top and 5 on the top, which if I multiply those together, I'm going to get 35 plus 50 is 85 degrees. So I like to reduce before I multiply on these ones just because I don't want to create big numbers. But you can do it however you want to. Just make sure you reduce correctly. All right, let's go ahead and move on here to number 14. Find the value of the trig function indicated. So for this, it might be helpful to remember this. Now this thing only helps us with sine, cosine, and tangent. There are other ones. Let's go ahead and see. This one happens to be a sine. Now sine is opposite over hypotenuse. So sine of theta is opposite over hypotenuse. Well, if this is my theta, my opposite side would be here, and my hypotenuse would be here. So opposite over hypotenuse would be 10 over 11. And that's the end of it. Okay. Let's look at another one here. Cosine. Got another one to do. So cosine of theta is adjacent over hypotenuse. So if here's my theta, this side here is my adjacent side, and this is my hypotenuse. So we have 24 over 8 radical 10. Now in this case, we're going to have to simplify this one a little bit. I know that 8 goes into 24 3 times. So now I've got 3 over the square root of 10. But another thing that we have to keep in mind is we're not supposed to leave square roots in the bottom. So I'm going to multiply the top and the bottom by the square root of 10, which will give me the following. And at that point, we're as simple as we're going to get. So that is going to be the cosine of angle theta there. Go ahead and take a look at number 18. Find the measure of each angle indicated and round to the nearest tenth. So to do this, you want to identify your reference angle. You want to label the sides that are given to you. That's opposite. And this is hypotenuse. And then we ask ourselves, which trig ratio? Is it sine, cosine, or tangent? Which one of those three uses opposite and hypotenuse? Well, it's sine. So we're going to have sine of theta is equal to opposite over hypotenuse. I don't know my angle, but I do know the opposite is 6, and I know that the hypotenuse is 13 over 2, or 13.2. And now I need to find the angle. So I need to get rid of this sine so I get theta by itself. And the way that we get rid of sine is by doing arc sine on both sides of the equation. And for that, we're going to need to use a calculator. All right, so on the left side here, the sines cancel out, and we're just left with theta. And on the right side, if we punch that into our calculator, I get 27.0, so I'll just say 27 degrees. It says round to the 10th place, but the 10th place was a 0 for me, so I'll just leave it as 27. And there it is, 27 degrees. So that's number 18. Let's go ahead and take a look at number 20. The steps for this one are pretty similar, it's just the last step is a little different. Identify your reference angle. Label the sides that are given. So this is my opposite side, and this is my adjacent side. And then we have to pick a trig ratio that uses opposite and adjacent. So that would be tangent. Tangent of theta is equal to opposite over adjacent. Now in this case, I do know my theta. My theta, the angle, is 53 degrees. My opposite is 11, and the adjacent is x. So what we're going to do now is we're going to get that x by itself. So the first thing that we're going to do to get x by itself is we're going to multiply both sides by x. And then we're going to divide both sides by tangent of 53. And now I've got x by itself. x is going to be equal to 11 over tangent of 53 degrees. All right, and so we'll go ahead and punch that into our calculator and see what we get. And I'm getting 8.3 if I round it to the nearest tenths place. Okay. So as you guys can see, all the steps were the same until we got to this part here where we have to solve for x, because it's just a little bit of a different kind of equation at that point. There it is. All right, and for number 22, it says find the missing side of each triangle. Leave your answer in simplest radical form. Now notice that this is not a special right triangle, and they give me two sides. And when we have that situation, we're just going to go ahead and use Pythagorean's theorem. So you take each leg, you square them, meaning raise them to the second power, and you add them together. And that should be equal to the hypotenuse squared. Okay? Now, when you square a square root, they just cancel each other out, so you're just left with 13 there. On this one here, the square will cancel out that root, leaving us with 2, but it will square that 2. 2 to the second power is 4. So what we're left with here is 8 plus 13 is equal to x squared, which is 21 equals x squared. And then we just take a square root on both sides. Typically, when you take a square root, you do get a plus and a minus answer. But when we're doing geometry, we only take the positive answer. You should also try to break down your square roots, but 21 only breaks apart into 3 and 7, so there's no pairs to take out. So that is the simplest form of that answer. So the hypotenuse would be the square root of 21 for this particular problem. Let's go ahead and take a look at number 24. Now for number 24, we want to find the missing sides, but you'll notice that unlike this, the last one, they only give us one side. You'll also notice that this is 45 degrees. Now technically, you could use sine, cosine, and tangent to get your answers here, but that's not the strategy I want you guys to use. So whenever you guys see a triangle that has a 45 here, or a 30, or a 60, I want you to remember that those are special right triangles, and I want you to use that strategy instead. Now why? Because your calculator, if you use your calculator, is going to give you decimal answers. But on the test, what they're going to give you is everything's going to be in radical form, because they're assuming that you're using the rules for special right triangles, and they use radicals for that instead of decimals. So if you see a 30, a 45, or a 60, you can assume you're dealing with a special right triangle, so we want to stick with those rules. So when it comes to the special right triangles, the first thing you want to do, of course, is recognize what special right triangle you're dealing with. And I'm dealing with a 45, 45, 90 right triangle here. The next thing you want to do, you want to identify what side did they give you. In this case, they gave me the hypotenuse, and I'm being asked to find the legs, which are x and y. The next thing you want to do is decide how do you get from the side that they give you to the side that you want. In other words, how do you get from the hypotenuse to a leg? And we drew a little diagram for that back in that lesson. And how you get from the hypotenuse to the leg on a 45, 45, 90 right triangle is you take the hypotenuse and you divide it by the square root of 2. Now, whenever you have a square root on the bottom, though, you do need to rationalize to get it out of there. So that's going to be 6 square root of 2 over 2. And then the 2 goes into the 6 3 times. And so our final answer there is going to be 3 square root of 2. Okay? Now on a 45, 45, 90 right triangle, whatever one leg is, the other leg is the same. And so this one will also be 3 square root of 2. All right? So what triangle is it? What side did they give? And how do you get from that given side to the side that you want? And use the little diagram that I gave you guys for that. Let's look at another one. Notice this says 30. That's another special right triangle. What side did they give me? They gave me the long leg. Now, when you have a long leg on a 30, 60, 90 right triangle, you can get from the long leg to the short leg by dividing the long leg by the square root of 3. And once again, we're going to need to rationalize that. So I end up with 5 square root of 3 over 3. So there's my v Now how do we get from the short leg to the hypotenuse? For that, we multiply by 2. So I'm going to take my 5, square root of 3 over 3, and I'm going to multiply it by 2. In other words, 2 over 1. If I do that, the 2 and the 5 multiply together to make 10. The bottom is just 3. And so now we have 10 square root of 3 over 3. So there are 2 answers for the missing sides there, using the rules for special right triangles. All right, number 28. I want to convert these polar coordinates to rectangular coordinates. So these are polar, which means that this number tells me my r value. In other words, the distance the point is from the origin. And this number here tells me my theta value. In other words, how far it's rotated around the graph starting from the positive x-axis. Now, you don't have to graph this, but I'm going to graph this one just to get a feel for it. So the distance from the origin is 3 spaces. So I'm going to imagine a little bar here at 3 spaces. And now I'm going to rotate that bar 90 degrees. So I'm going to rotate it up that far. And that will put the end of the bar up there. And that end of the bar is where the point is. And I want to know, what are the coordinates for that point? Now, I gave you guys a little formula for that. The x value will be equal to the r value multiplied by cosine of the angle. And the y value will be equal to the r value multiplied by sine of the angle. And so in that case, we're going to end up with 0 here. And for this one, 3. And so the rectangular coordinates will be 0, 3. All right. Go ahead and move on to number 30. We want to convert these pair of rectangular coordinates to polar coordinates. I think I'm going to go ahead and change these though, because I don't like these things looking all ugly like this. We could do it. It's just, I don't know, it's just a mess I don't want to get into right now. We'll just kind of keep it kind of straightforward. There we go. Those are a little bit nicer. I think we'll work with that. All right, so I gave you guys some steps for this one. The step 1 was to go ahead and plot those points. So my points are over 5 and down 12. So that puts us right there. Step 2 is to turn this into a triangle. Okay, so I'm going to draw a line straight to the x-axis vertically. And we're also going to draw a line from the dot to the origin. That gives me a right triangle. Now on this right triangle, the base of it is 5, and the height of it is 12. Now we need to find 2 things in order to get this process underway. We need to find the angle here, and we also need to find the hypotenuse, which I'll call r here. So the third thing we did was we found the hypotenuse by doing Pythagorean's theorem. So we do the leg squared plus the leg squared is equal to the hypotenuse squared. And I end up getting 13 there for my r value. Now I need to find my missing angle. The way that you find the missing angle is by doing either sine, cosine, or tangent. Now, I think it's probably best to go with just tangent every time with these. So tangent of the missing angle is the opposite side divided by the adjacent side. So that would be 12 over 5. And then to solve for theta, we just do arctangent on the opposite side there. And let's see what we get for our angle. I end up with 67.4 degrees. Now that's this angle from here to here. That is 67.4 0.4 degrees. Now that's not the angle we actually want, though. We have to keep in mind the angle that we actually want starts up here at the positive x-axis and goes counterclockwise to here. Okay, so I need to find out what that arc is there for my final answer. Now I know that from, oops, that's too big. Here all the way to here is about 270 degrees. Or maybe you would have done a little differently. Maybe you would have said 180 and 90, but still that's 270. And then I still need to find a little bit more. I need to find out what this little portion would be. That's a missing piece, right? So if this is 67.4, what's the missing piece? Well, we saw earlier that you have to subtract this, the piece that you do know, from 90. So let's do that. 90 minus 67.4 would be 22.6. So this missing angle here would be 22.6. And that's what I'm going to add to the 270 to get the whole arc that I was looking for. And by putting those together, I end up with 292.6 degrees. So that's the angle that I want. And this is the R that I want. And so step 3 gives us the R, and step 4 gives us the angle. So the answer, number 30, will be 13, 292.6 degrees. Okay, and that's polar coordinates. Next one, it says plot the point with the given polar coordinates. So we did this earlier, but we'll just do an example again here. So the first thing you're going to do is you're going to go out that far on the x-axis, and then you're going to go out that far on the y-axis, on the left side and also on the bottom side. And you want to draw a circle that connects those three regions together like that. So I know that my point has to be somewhere on that circle. Now the question is where? Well, where is 105 degrees at? If this is 0, where's 105? Well, this is 90. And so 105 would probably be like somewhere like right about here. So if I were to start on the positive x-axis and rotate to here and go all the way up until that point was on the circle, which is 3 spaces away from the origin, that's where the point would be located. Okay? And there you guys have it. So that's how you plot polar coordinates. And that's it. So that's what will be on our exam. Hopefully it was helpful. We'll see you guys in class. Till then, have a good day.